Hey guys, Darren Giuseppe here, back again with another video for the Key Concept series. In today's video, what we're going to look at is a question on binomial expansion. And this is a question that comes up in Module 2 of Pure Maths Unit 2. Comes up a lot. So let's go through the solution to this question. So part 1 is asking us to write down the binomial expansion of 1 plus 1 and 4 by x, all being raised to the power of 5. So from the time I see this is being raised to the power of 5, that's a positive integer. So therefore I will use the binomial expansion for positive integers to expand this here. Alright, so what we will have first up is basically this here, and we need to use the expansion for positive integers. So that would be the expansion with NCR. That is what I'm going to use here. And we just write it out and we'll talk a little bit more on it. So this is basically an initial setup with all the NCRs, right? So that's cool. Everything good there, right? You could just stop it, make sure you understand everything and everything is correct. Then what we want to do is simply just break it down, right? So by now everybody should know this formula and should know it by like the back of their hands, right? If you write in exams, and it's just a matter now, once you put down the formula, it's just simplifying, plugging in stuff into your calculator so you could get what these terms actually are, right? That's what you need to do next. So this is what we have happening here when we do our simplification using our calculator. And you'll notice that a few terms could simplify a little bit more. This and this could simplify a little bit more. So in the end, this is what we have happening here. And this here is our solution for the expansion of this here. And that is basically it, right? That is your solution there. So the key with this is really just making sure you know your formula. Once you know your formula, you can get to this point very easily because it's just a matter of using your calculator thereafter. Let's look at the second part, right? The second part, let's get into that as well on our next page. The second part is saying, hence, calculate 1.025 to the power of 5, correct to 3 decimal places. Correct to 3 decimal places. So what do we have to do here? That is the question. They say hence. Hence usually means using the information from the previous part, right? So what I would do is, let's put down this 1.025 to the power of 5. Let's put it down. And let's kind of rewrite it a bit, right? That's the same as 1 plus 140 to the power of 5. Kind of looking back at this, right, at the same time. Look back at, right, what was given in the first part, because the hence means to use the information from the first part. So let's see how we could use that. The next thing we could do is, you could see this is the same as a quarter by 1 on 10, right? So we could kind of set it up to look kind of like this. Seeing that, right? So this is what we would have here. So isn't this here kind of like the same thing as that we had in part 1? Looking like the same thing. So things looking really nice here. We have the quarter, but in the big difference between this here and this here is that x is now 1 on 10. So what I would do simply, right, to calculate this is I would simply, wherever I had x in the previous expansion of this in part 1, I would replace x with 1 on 10, right? And quick notice, quick thing to note, if you just give the answer here using your calculator, plug 1.025 to the power of 5 into your calculator and give the answer and correct it to 3 decimal places, you will get it wrong. The hence means that you have to use this, They didn't say otherwise. If they did say hence or otherwise, you could have probably plugged it into your calculator, but they only say hence. Hence means you have to use the information from the previous part. So just to plug that in quickly, right? For those who thinking you could just plug it into your calculator and get the answer, no. The hence means you have to use the information from the previous part. So what I would do, right, we notice that the difference here and here is that x is 1 on 10 here, and that's basically it. So I would just plug in wherever I had x in the expansion of this that I did in the previous part, right? I would plug in 1 on 10 as I said before. So this is what we will have happening here. 1 on 10. Wherever I had x, I put 1 on 10. And in the end, this is what we will have here. All we do now simply is we plug this entire thing into the calculator, or you could work them out individually and just put them down and then find the sum, right? Or plug it into a calculator. That might save your time. And in the end, this is the entire figure that I got on my calculator. They asked us to correct it to 3 decimal places. So when we do that, 3 decimal places is 1, 2, 3. This term here is less than 5, so it wouldn't increase the third decimal. So your answer should be 1.131, correct to 3 decimal places. So this is our answer here, and you could actually use your calculator to double check. Plug this into your calculator and you should get, well, not exactly this, but it will approximate to that, right? When you approximate it to 3 significant, not 3 significant, but 3 decimal places, right? So guys, this is another question, and just quick note, right? This is basically an application of binomial theorem. So apart from them asking you to expand certain things where binomial expansion is concerned, they love to ask application questions. So that is basically what they do there. And yeah, this is just another question. This is the solutions for this particular question. Guys, I hope you understood this one. Share it to a friend that you believe it can help. And like the video, subscribe to the channel, all those nice things. And I will see you in the next video.